2, we are practicing how to calculate all these things associated with standard deviation. And the first thing that we need to start with is we need to start with what is n. So if you don't remember what n is, let's talk about that now. If anybody remembers what n is, let me know in the chat. And if you don't remember what n is, then you can start trying to remember what is x bar. So I got that quite a bit last class period. N is not the mean. It is a variable, but n stands for something specific in these equations. It stands for the sample size. Yep. So how many samples did you take? So for example, for sample set 1, how many measurements did we take there? What is our sample size? And remember, post it in the chat. And while you guys think about that, can anyone tell me what x bar means? An X with a line over it. All right, somebody has told me that x bar is the mean, also known as the average. Okay, nobody can tell me what my sample size is for sample data set 1? 3, excellent. I got 3 measurements from Eric, Stan, and Kyle. And yeah, whoever wrote this was watching South Park. Because you'll see Kenny's on the next data set. Okay, so the next thing we need to do is we need to calculate our mean. Our mean is the sum of all of our data points divided by n, which in this case is 3. So I want you guys to open your calculators, calculate that, and I'm going to wait for at least 2 people to share their mean with me so we can double check each other's work. And just a note, no. I think you forgot to divide by n, Josh. Better, Eddie. So let me make a note. If you have ever taken AP Chem, or I don't even remember, you might learn this in regular Chem as well, you will have heard about significant figures, which will tell you how far you need to round something. We don't deal with that in AP Bio, for which I'm very thankful because I don't remember sig figs. I know, don't tell your chemistry teachers that. But what we're going to do on the AP test, they will always tell you what digit they want you to round to. So they'll say to give your answer to the nearest 10th or the nearest 100th place. Since in this set of data, we have everything to the 10th place, let's round to that. So I agree that it's 160, but what should come after that decimal point if we're rounding to the 10th place? So let's say we have the number 160.1666 going on for forever. If I want to round to the 10th place, I need to look at the next digit after that, so the 100th place. If that number is 5 or above, then I'm going to add 1 to the 10th value. If that number is below 5, I'm going to round down. So it's just going to stay 160.1. But since that next number is 5 or above, it's going to be 160.2. Now, on the AP test, on the FRQs, usually for anything where they have you calculate, they will have a range of values that they'll accept. So if you round a little differently, it shouldn't be a problem. But if you take that number you rounded and you use it in another calculation, and you round differently, and you use it in another calculation, you run the risk of being so far off that you lose the chance to earn that point. So that's why I wanted to go over rounding. So now we have a mean calculated for this data set. I will try and do a lot of these more complicated formulas. I will give you charts to fill out for them because you have to do a lot of small calculations. Luckily, on the AP test, I have never seen them ask to calculate a standard deviation. The most I've seen them do is ask you to explain what a standard deviation means. However, it helps if you run through these calculations, especially if you're a more math-focused person. So next we need to calculate our deviation, which is each individual data point, how far is it from the mean? And the reason we're doing that is our standard deviation is we're looking at the spread. How far is this from the mean, or how close is it to the mean? So for Eric, that calculation is going to be his height, 150.5, minus our mean. And our mean, as we calculate it, is 160.2. So, do the math. Tell me, what is 150.5 minus 160.2? And I want to see answers from at least 2 people. No. Check your math, Josh. Calculators. Calculators are useful here. I know some of you guys are proud of your mental math skills, but just use a calculator. It makes sure that you get an answer that is more accurate. Especially if, like me, your math skills go to crap when you're tired. So the answer is negative 9.7. Then let's do this for Stan. So for Stan, that value is going to be 170 minus 160.2. And what is that? And I need to see at least 2 answers before I will tell you if you are right. All right, 1 answer, 2 answers. All right. It is 9.8. Nice job, guys. Sorry, for some reason I started writing a 5. All right, and then last of all for Kyle, it's going to be 160 minus 160.2. All right, I've already got 1 answer. I need 1 more person. I got 2 answers. It is negative 0.2. Nice work. I am including the sign here just because it is important in one of the equations we will deal with in another lesson to keep negative signs because they tell you something. So try to keep the signs accurate. The next row, we're going to take our, oh, and just want to point out that since we have this shaded in box down here, that means we don't need to do anything with it. We are not making any calculations there. We leave it blank. And then our next calculation is going to be, Zoom wants me to do something. This. We're going to take the value we got from the previous table and we're going to square it. So for example, for Eric, we're going to take negative 9.7 and multiply it by negative 9.7 because if your calculator is like mine, it does not have a square button. At least the calculator on my phone doesn't. All right, so I need to see at least 2 answers in the chat. What is negative 9.7 squared? All right, and let's round it to the 10th place. I need an answer from 1 more person. And it doesn't have to agree with the first answer. What do you get when you multiply a negative by a negative? Well, a negative times a negative gives you a positive. Squares are always going to be positive if you square something. The only time that doesn't happen is when you're dealing with wonky math and you're dealing with imaginary numbers. But in biology, We don't deal with imaginary numbers. So you are going to have a positive number in this column. This column will always have a positive number. So it's going to be 94.1. What is the squared deviation for Stan? All right, I need to see one more answer. All right, 96.04. If we round that to the tens place, it's going to be 96.0. Yep. All right, and then Kyle. What is Kyle's squared deviation? All right, I got one answer. Let me see a second one. All right, good. It's 0.04. I know I could round it to the tens place, but since it's the only one we got, only digit we've got, I'm gonna just leave it like that. All right, now our next thing is if you see in the bottom of that column, we now need to add all the values we got in the table up. So basically it's like we put a giant line and a plus sign right here. So what are those three values added together? What is their sum? Mm-hmm. All right, I got two answers. They both agree with what I got, so we're going to hope my math skills are doing good right now. And let's just round that to 190.1. Now, note, that is not our standard deviation. Our standard deviation, the formula for it, is down here, because S is our standard deviation. So we still have some math to do, but notice that we have already produced, let's say, this term right here, the sum of all of these squared deviations is this number up here. So we already have most of that equation completed. So now all we have to do is standard deviation is going to be the square root of the number we calculated, 190.1, divided by n. What is our value for n? It's 3 minus 1. And since it's a square root, it's going to be a positive number. Because imaginary numbers don't exist in bio. At least not in my bio. If you do biology with imaginary numbers someday in research, let me know, because I want to know what that is. That would be freaky. Also, I want to point out when you're putting this on your calculator does not automatically, well, it automatically does order of operations a little differently. The way you should enter this in your calculator is square root symbol, open parentheses, 190.1 divided by 2, close parentheses. Because otherwise, it's going to take the square root of 190.1, and then it's going to do the rest of the math. All right, what's my standard deviation, guys? All right, and we can round, so let's make that 9.7. What that means is that if I was taking, let's say I was taking a graph of all the heights of people in the town of South Park. What I expect from this, if this is my mean, then I expect a normal distribution, a bell curve, and here's our mean. And sorry, straight lines are not easy for me to draw on this graphic tablet. When I draw straight lines, I tend to celebrate. And this is one standard deviation down from the mean, and this is one standard deviation up from the mean. What that standard deviation is telling you is most of the data is in that point. Let's say we got a different data set, and let's say that this was our standard deviation. What that would tell you is that would tell you that your data is really spread out, meaning you have a wider range of numbers and you have more numbers that are farther from the mean. And then if you had a different data set, let's say where this was your standard deviation, then that would mean you have a much narrower range of numbers, or more of the numbers are closer to the mean. There's not a lot of variability or difference in your measurements. So for example, when we were talking before, we were talking about if you measured the heights of all the basketball players on the Mavs, then you would probably expect to find them to have a small standard deviation because most of them are on the taller end, so they should probably cluster or gather around the mean of the average heights for those players. On the other hand, if you took the standard deviation of the heights of everybody in the city of Dallas, you should get a much wider range of numbers and a lot more variation from the mean, meaning you're going to have a bunch of variety in height. And so you should have a larger standard deviation. So going back to our calculating, what you hopefully have kind of gotten from some of the reading that you've been doing on those handouts is the fact that the standard error of the mean, which is this guy right here. And by the way, if you're like, that's not saying standard error of the mean, that says SEX bar. X bar is mean. And so what you're going to be doing is to calculate that, you're going to take your standard deviation, which is this number right here, and you're going to divide it by the square root of n. Let's talk about what that means real quick. Your standard error of the mean is basically saying you have taken a sample from a population and you are using that to calculate a mean. But the sample does not necessarily reflect the entire population. Because if I was sampling the average height of people in the city of Dallas, but I was using only the Mavs for that, is that representative of the mean for my entire population? Probably not, because I just got this small sample. So, in order to try and have confidence about whether your sample mean is close to what the actual population sample mean would be, you have this measurement called standard error of the mean. And when you calculate it, it tells you what range in which the actual real standard deviation of the entire population, all of the city of Dallas, would be. And note, on the bottom is basically your n, your sample size. What that means is when your sample size gets bigger, your standard error of the mean gets smaller. So this is part of why we want such a large sample size anytime we're doing an experiment, because the larger the sample size, the smaller the standard error of the mean, and the more confident we can be that the mean we calculated in our experiment is pretty close to the actual true mean of everyone in the population, because it's not practical to take the height of every single person in the population. You'd be measuring for years, and by then some people would have died, some people would have been born, some people would have grown, and it would just be crazy. So let's go ahead and calculate this. So our standard error is our standard deviation, which is 9.7, divided by the square root of our n, which is 3. So guys, do the math. I need at least 2 answers telling me what that is, so that way I can verify. All right, speedy guys. We've got 2 answers already, and they are correct. The standard error is 5.6. Since it's 5.60000, we round down to 5.6. Then the next thing you're asked to calculate is this thing. What is the mean plus or minus 2 SEM? So that's a pretty standard measurement that you're going to potentially see on the AP test. It's what we use to draw what are called error bars on our graph. And it will let us see how confident can we be that these results are actually different from each other. And we'll talk more about that when we do a graph in a second. So now we need to calculate what is our mean plus 2 times the standard error, and minus 2 times the standard error. So here's how we calculate that. We take our mean, and we're going to first add to it 2 times whatever our standard error is. And then we're also going to take our mean, and we're going to subtract from it 2 times the standard error. So for this grouping, for this data set, that's going to be 160.2 minus 2 times 5.6. Oh, sorry. I'm gonna change that. So the bottom one's gonna be plus and the top one's gonna be minus. My bad if I confused anyone. And then the second one is 160.2 plus 2 times 5.6. Once you get those numbers, put them in the chat so we can verify them. And you shouldn't need any parentheses on this because your calculator can do those order of operations just fine. So what's the lower value? What's minus 2 SEM? The mean minus 2 SEM. Okay, I've got an upper value. I need a confirmation on the upper value and 2 people telling me the lower value. All right, I got 1 person for the lower value. I need confirmation for each of those. Have I lost y'all with the math? Are y'all like, oh my god, my brain has leaked out of my ears? I am sorry. There's a reason why this is being recorded so that you can go back and you can watch it. I know I'm rushing just a little bit, but the reason is I want you to have enough asynchronous time. All right, so our lower value has been confirmed. It is 149. And I'm just going to confirm for you the upper value is indeed 171.4. All right. Now, what I want us to do is you guys are going to calculate the numbers for the sample set 2. But while you guys are going to do the math and I'm not going to write out the formulas, we're going to go through this number by number and I will verbally review with you. So first thing we need to do, we need to start over on the left side of the table and we need to figure out what is our n. So one person, tell me what the n is. Another person, start calculating the mean so you can tell me what the mean is. All right, so I've already got the n is 3. What is our mean, our x bar? All right, so I've got 169 as my mean. All right, now we need to start calculating the deviation. So somebody calculate the deviation for Kenny and tell me what that is. Another person start calculating the deviation for Timmy. And another person start calculating the deviation for Randy. And if you have the urge to say, Timmy, I understand. And make sure you tell me whose deviation you calculated. Because if you just throw a number up there, I'm going to be like, who is it? Oh, this isn't accurate. Randy is Stan's dad. He should be much taller. All right, so for Randy, we have a deviation of 6.5. For Kenny, it's -8. And, oh, come on, guys. Timmy needs some love, too. Sorry, I love Timmy. All right, Timmy is 1.5. Now we need to square those. So we need to calculate the squared deviation. So once again, somebody calculate it for Kenny, somebody for Timmy, somebody for Randy, and let me know in the chat who you're calculating it for when you give me the number. Also, keep in mind, it's going to be a positive number. And remember, you're just multiplying the deviation by itself, and that'll give you the squared deviation. Okay, so Randy is 42.25. We're going to round that to 42.3. Kenny is 64. Once again, Timmy don't get no love. 2.3 for Timmy. Now, let's calculate the sum of all those. So add them all up. Just for this, I'm going to start sticking pictures of Timmy in y'all's notes. Okay, 108.6 is our sum of our squared deviations. Now, we need the standard deviation. So we're going to take that number we just calculated right here, and we are going to divide it by n minus 1, and then take the square root of all that. That's going to give us our standard deviation. So when you've got it, put it in the chat. Let me know what it is. And by the way, everything underneath where it says procedure part 1, we're doing all of that. All right, I've got 7.4. Is that bigger or smaller than our deviation, standard deviation for sample set 1? It's smaller. So we have less variability or less difference or spread in our data in sample set 2. Notice in our first sample set, the difference between the largest and the smallest value is a whole 20 centimeters. But in our sample set 2, the difference between the largest and smallest is only like 14 centimeters. So we've got more variability in sample set 1. All right, hopefully while I was pointing that out, somebody got started on the sample error of the mean, which is our standard deviation divided by the square root of our sample size. What do y'all calculate for that? All right, I've got 4.3. Do we agree with that? I feel like the videos are just dropping like flies. We're almost done, guys, I swear. All right, so 4.3. Now we need to do what is the mean plus, no, let's do minus first. It's the first blank. The mean minus 2 times the standard error. It's okay, Josh. I understand. It was just a trend. I've gotten several other messages that people had to turn their cameras off. I'm just starting to feel lonely, especially because Ivan keeps throwing up deuces at me like he's about to leave. All right, guys, what is the mean minus 2 times the standard error? And then whoever's not calculating the mean minus 2 times the standard error, calculate the mean plus 2 times the standard error. So we've got 160.4 as our lower value. What is our upper value? 177.6. Excellent. All right, so we've got all this data. Generally on the AP test, though, that's not going to end this. Instead, you are going to have to graph or interpret a graph. So what they're showing you here is that when you're doing a bar graph, actually when you're doing a line graph too, you can add these error bars which help you to see, to visualize, oh, okay, my standard error of the mean is really big, which means I can't be really confident that the mean that I calculated is the actual mean for the whole population. Or if your standard error of the mean is really small, that means you can say, I'm pretty confident that this mean that I got matches the actual mean of the entire population. So let's do some graphing down here. And I'm going to go through the graphing a little more quickly than I would like to because I have eaten up into so much of your asynchronous time. My bad. All right, so we are graphing on our y-axis height. And when we talk about graphing in more detail, we will emphasize the fact that you always label your axes. And then down here is sample data set. Now, I have a bit of an edge because I had to do this in 5th period, but what we can do is we can say, okay, what is the lowest value I'm going to need to graph? What is the highest value I'm going to need to graph on the y-axis? Well, I'm graphing means, and then I'm graphing that plus or minus to SEM. So that means that my lowest value that I'm going to have to graph is 149. And my highest value that I'm going to have to graph is 177.6. So I need to make sure I can show that range accurately on my graph. So I'm going to say I'm going to graph up to 180. So if I do that, I look at the number of squares I have here, and it looks like I have quite a few. So let me see what happens if I count up by tens. So let's say this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And notice I'm putting those tick marks on the side. That shows me exactly where that value that I've written off to the side is. So I know that 100 centimeters is directly on that line. If I don't put that tick mark there, it could be anywhere along the side, and it gets confusing. So 120, 140, 160, and luckily for us, 180, it matches up. So then, our sample set 1. So we're going to make this is going to be set 1, and we're going to make this be set 2. So I need to first draw a bar that goes all the way up to the value of the mean. So for set 1, my mean is 160.2. So I'm going to go ahead and do that graph. It's going to be just a hair above 160, so let's say around here. And then, like I said, straight lines are not my friend on this graphic tablet. Actually looks better than normal. That's kind of sad. And then let's go ahead and let's draw the error bars. So my lower error bar value is this 149. My upper value is 171.4. So what I'm going to do is I'm going to mark, where is 149 on this graph? Well, here's 140. This would be 150. So 149 is going to be just a skosh below that. So I'm going to draw a horizontal line there. My top value was about 171. So 171 is going to be a hair above 170, so around here. So I'm going to draw a horizontal line there, and then I'm going to draw a line between those. Those are my error bars. So my actual mean for this population of humans in South Park should fall within the range of those error bars. We have confidence, or some confidence, that it can. Now we're going to draw the second set of error bars and data and so on. So our mean for the second set is 169. that means that we are going to... Yes, question?
I have a question. Are we supposed to have that second part on the like the presentation?
I don't
Like
understand.
for me, I just have the first part.
You just have the first page, that's it?
Like on the slides, the ones that you post. Yeah.
Okay, let me go check. I may have changed it later. I will put that second page up. Okay, I'll do that during asynchronous
Okay.
time. Thanks for letting me know. All right, so here's sample set 2. Can you believe no one in 5th period told me they were missing an entire page? Nuts. All right, and then our error bars will go down to 160.4 and up to 177.6. So 160.4 will be around here, say, and then 177.6, this is 170, and I'll say it's around here. And then we join them. So notice we've got smaller error bars on group 2 or sample set 2. We've got bigger error bars on sample set 1. We can't be quite as confident about that mean being close to the actual mean of the entire population. So at this point, I am going to stop recording. I am going to let you guys